In this session, I'm going to introduce to you functions, and we're also going to talk about the domain and range of the function, what are the different types of function we can have, and once we've explored the different types of functions we have, how we can actually test which type of function exists using two very specific tests. And then to conclude the session, we're going to actually look at how we can find out the inverse of a function in an algebraic manner. And also, we're going to explore what's the purpose of the inverse function, what it actually does. So let's jump into it and check how we actually write a function. But before we actually start to talk about function, it's good that we refer to the equation of a curve or a line, which usually starts with y is equal to something. So it's usually y is equal to a function in x. By function I mean terms in x grouped together. So let's say that's our equation. Y is equal to x squared plus 3x plus 2, which is a quadratic equation. This is how you're used to writing the equation. It always has been y in terms of x. So now we're actually going to say that the y is going to be replaced by fx, where fx is the function in terms of x. So fx stands for function in x, which basically means an equation in x. That's what it means, all right? And that's one way of writing it. Another way of writing it would be like this, the way I'm writing it on the right-hand side. X squared plus 3x plus 2. So it's read like this. It means f is such that x is mapped onto x squared plus 3x plus 2. So the arrow means mapped onto. And what does map onto means? It means that you're transforming. Okay, you're transforming x onto x squared plus 3x plus 2. So how does it really work? To explain to you how it actually functions, yeah, I need to show you how the mapping is done. So what you're basically doing is that you're taking a value x and you're converting it into x squared plus 3x plus 2. Okay, so x is changed into fx. So let's say I take x as 0. Okay, so the equation is fx equal to x squared plus 3x plus 2. Or it can be written as that, like we said. So if x is 0, I get f of 0 is equal to 0 squared plus 3 times 0 plus 2. And this becomes 2. So we can say that x is changed into 2. Okay? Or 0 is mapped onto 2. If I replace x by 1, I get f of 1 is equal to 1 squared plus 3 times 1 plus 2. So this becomes 1 plus 3 plus 2, so 3 plus 2, 5 plus 1, 6. So 1 is changed onto 6. All right? So you're basically taking input values, you're inputting the input value in the equation, and then you're getting an output value. So these values here are referred as input values. Another name which is given to them is domain, or sometimes we call these values objects. And these values you're getting as output values, they are called output values, like I just said. Output values, sometimes we call them range, and sometimes we call them images. Okay, so all these words mean the same thing. And for exam, you're actually going to get one of these key terms in your questions, and you need to know what the term means. All right, so this was actually the first part of what I wanted to explain to you, domain and range. So domain means the x values and range means the y values. All right, so that was the very fundamentals of functions. So your equation y is equal to x squared plus 3x plus 2 can be written as fx is equal to x squared plus 3x plus 2, so the y gets replaced by fx. Then we actually look at taking values and inputting in the function, which we did here on the right hand side. I first replaced by 0, so I just use this equation. X gets replaced by 0, so you get f of 0 is equal to 0 squared plus 3 times 0 plus 2, you get 2. And then if I replace by 1, I get 6. So 0 is changed into 2, and 1 is changed into 6. Okay, and all the input values are called domain or objects, and the range or output values or images all mean the same thing. The things we get out after that we've replaced. Okay, so that was the first part of the session. What I'm going to do now is I'm going to focus on the second part of the lesson, and the second part of the lesson is about types of functions. But before talking about types of functions, it's good to have a definition for functions. So how would we define a function? If I had to define a function, I would say that each input value has one output value. That's how I would define a function. So every time you take a value you input in the equation, you should get one output value. So let's check that out. So let's say I have fx equal to x plus 1. Okay, and we draw our arrow diagram. So let's say I replace 0, I get 0 plus 1, 1. I replace 1, I get 1 plus 1, 2. I replace 2, 2 plus 1, 3. Okay, so each input 0 has one output 1. Input 1 has one output 2. Input 2 has one output 3. Okay, so each input has one output, so it actually it actually matches quite well our definition of function. Okay, now you can have another function. So let's take a quadratic curve and see whether it matches the definition. So if I replace by 0, 0 squared gives me 0. If I replace by minus 1, minus 1 to the square gives me 1. If I replace by 1, okay, I still get number 1. So does it match the original definition? Each input should have one output. So input 0 has one output 0. Input minus 1 has one output 1. Input 1 has one output 1. So it does match the function definition. However, you have two arrows going towards 1. So we call that a many-to-one function, because you have two arrows going towards the same number, you see? Whereas the first one is a one-to-one function, whereby each input has one output, and actually each output has one input. So if each input has one output, like input 0 has one output 1, input 1 has one output 2, input 2 has one output 3, so each input has one output, and each output has one input or comes from one input, we call this one a one-to-one function. Whereas this one, each input has one output, so input 0 has one output 0, input minus 1 has one output 1. However, each output, so output 1 has more than one input. Okay, so this one is a many-to-one function. All right, and yeah, these are the two types of functions we can get. All right, and now, before we jump onto the next part, what we need to know is that if we have a one-to-one function, its inverse is possible. Okay, its inverse is possible. So you can find the inverse of a function if it is one-to-one. If it's a many-to-one function like the quadratic one, the inverse is not possible. Okay, unless we restrict the domain, and this is what we're going to look into next. What does it mean unless we restrict the domain? We're actually going to explore that. All right, so we've talked about the different types of functions. Let's have a look at how it looks like if we draw the function. So I'm going to take the first one, which is fx equal to x plus 1. I'm going to do a very quick sketch. So fx equal to x plus 1, so that's a straight line, positive gradient, so it should be going up. And the y-intercept is 1. You can refer to y squared to mx plus c, so the c is 1. So I know it's crossing the y-axis at 1. So the line looks like this. Now, if you have a graph and you need to check whether it's a one-to-one function, then what needs to happen is we need to do something called the horizontal line test. So we have a test called the horizontal line test, whereby, like the name suggests, you draw horizontal lines on the graph. And if, so let me just write it here. So horizontal line test. So if the graph crosses, sorry, let me just rephrase it. So it should be read as if the horizontal line crosses the graph once, okay, it passes the test. It passes the test, and therefore the inverse exists. Okay, so that's how we can check whether a function is one-to-one. We draw a horizontal line on it, and if it's crossing the curve at one point, we know it's a one-to-one function. So you can see here that everywhere I draw the horizontal line, if it's crossing the original graph at one point, therefore it's a one-to-one. Okay? So that's what I meant by it. So in the category test, we looked at the horizontal line test. Okay? So that was for the first one. Let's look at the quadratic curve now. So let's look at fx equal to x squared, which is the second one. So I'm just going to erase that, and then I'm going to draw a quadratic curve. So it's fx equal to x squared. So a quadratic curve looks like this. Okay, and here if you draw a horizontal line, you'll see that's going to cross at 2 points. You see? So it's failing the horizontal line test. So therefore, it's not a one-to-one. However, if I consider half of the graph, like this one, the right-hand side of the parabola, this is called the parabola. If I draw horizontal lines, what happens? It crosses at 1 point only. So this is where domain restriction comes into place. So if x is greater or equal to 0, it's one-to-one. Or if x is less equal to 0, it is one-to-one. So the inverse is actually possible if you restrict the domain. You can either consider the left-hand side or the right-hand side. Okay, I'm going to draw the parabola again. So it looks like this. If I hide the left-hand side, if I hide this part will pass the one-to-one function, will pass the horizontal line test, so that you can conclude it's a one-to-one function. Or the same way, I could hide the right-hand side, and it will pass the horizontal line test on the left. Okay, so this is what I meant by restricting domain to determine whether it's a one-to-one function. All right. Now, just to finish the session, we are actually going to look at the steps involved in finding inverse of a function. Okay. How do we find the inverse of a function? So we're first going to take a simple one. So let's say fx equal to root of x plus 2. Okay, let's say that's the original function. No, that won't be a correct one. Let's say I take a linear equation. So fx equal to 5x plus 4. Okay, so let's say that's the function, and we need to find its inverse. I'm first going to write down the steps on the right-hand side. So the first step is replace fx by y. Number 2, make x subject of formula. Step number 2. Step number 3 will be interchange x and y. Step number 4 will be replace y by f inverse of x. So let's see how it works. So step 1 is replace fx by y. So y is equal to 5x plus 4. Step number 2, make x a Becker formula. So y minus 4 is equal to 5x. X will be y minus 4 divided by 5. Then interchange x and y. So where you got x, you write y. Where you got y, you write x. This. Step number 4, replace y by f inverse. So f inverse of x equal to x minus 4 divided by 5. Now let's see how it works. I'm going to draw my arrow diagrams here. So x and fx. So let's say I replace x by 0. I get 5 times 0, 0. 0 plus 4, which is 4. So under the original equation, 0 is converted to 4. What the inverse function should do is it should take the 4 and then make it become 0. So if I take 4 and I replace in the inverse function, so I'm going to do it here, f inverse of 4, and I use the new equation I've got, which is 4 minus 4 divided by 5, what happens? I get 0. So when I replace by 4, I'm getting back 0. And this is what the inverse function does. It does the reverse of the initial process. So the original function took 0, I've replaced x by 0, it gives me 4. Whereas the inverse function takes 4, okay, f inverse of 4, you replace it in the new equation, 4 minus 4 divided by 5, and it gives me 0. So this is what the inverse function does. And for you to be able to find an inverse function, it should be a one-to-one function. So that's where the importance of knowing what kind of function you have becomes very important.